In this session of laws of motion, we are going to discuss a problem. This problem is the net force acting on a block by the wall. Now what you can see, the man is holding an object against this wall. We are going to discuss the force acted by this wall on this object. For this we have to draw the free body diagram of this object. That means what are the different forces that can be applied by the surrounding on this object. The forces which are acting, one is gravitational force, that is the basically mg, vertical downward. Another one is the force acted by the man. Next is the force acted by the wall, which is called the reaction by the wall. And the last one is the frictional force acted by the wall on this object. Our point of interest is that what is the net force acted by the wall on this object. Now consider this numerical example. Consider this block which is pushed against the wall by the application of 12 Newton force. There is a friction between the wall and the block. The coefficient of static friction is 0.6 and the coefficient of kinetic friction is 0.55 between the wall and the block. And our purpose is to find the net force exerted by the wall on this block. The force exerted by the wall on the block are two. One is the normal reaction, another one is the friction force. And the normal reaction and the friction force are the contact force exerted by the wall on the block. And these two forces are perpendicular to each other, right? This is the normal reaction and this one is the frictional force. And the net force is given by from triangle law of vector addition, and which is given by P, and this P will be equal to root over r square plus f square, right? This net contact force or net force exerted by the wall on the block is given by root over r square plus f square. Now in this problem, we do not know about the motion of the block, whether the block is at rest on the wall or it is moving on the wall. Hence, we have to assume that the block is at rest on the wall. That means block is not sliding along the wall, right? But the block has the tendency of relative motion vertical downward. Hence, the frictional force acting on the block will be the static frictional force, which acts upward because the tendency of relative motion of the block is downward. The value of static friction force acted on the block by the wall must be less than or equal to limiting static friction force if our assumption is true, otherwise it will be wrong. First of all, we have to check that our assumption is true or false. Draw the free body diagram of this block. There are different forces acted on the block by the surrounding. One is 12 Newton force, another one is the gravitational force mg, that will be equal to the weight of the block 5 Newton, which is acted by the earth. Third one is the force exerted by the wall on the block, that is the normal reaction. And the fourth one is the frictional force F, which will act vertical upward because this block has the tendency of relative motion downward. Now we have to find the value of F and compare this value with limiting static friction force Fs. Apply Newton's second law along the vertical direction and the net force on this block equals to 5 minus F. This 5 minus F will be equal to mass into acceleration. As the acceleration of this block is 0, hence 5 minus F will be equal to 0 and hence friction force will be equal to 5 Newton. That you can see in this equation. 5 minus F equal to 0 by applying Newton's second law along y-axis or along the vertical direction, and then F will come out 5 Newton. Now our next purpose is to find the value of limiting static friction force. This limiting static friction force equal to mu s into r, and the value of mu s in the problem is 0.6 and the value of normal reaction is 12 Newton. To determine the value of normal reaction r, you have to apply Newton's second law along x-axis. 12 minus r will be equal to 0 because the block does not have any acceleration along the horizontal direction, hence r will come out 12 Newton, right? Using the value of mu s given in the problem and the value of the normal reaction, that will be 12 Newton, find the value of Fs, which will come out 7.2 Newton. As the value of limiting static friction force is 7.2 Newton, which is greater than the static friction force 5 Newton. Hence our assumption is true because if the block is at rest on the wall, then the block will have the tendency of motion. Hence limiting static friction force must be greater than the static friction force. So that's why our assumption is correct and the friction force acting on the block is 5 Newton. Hence the force exerted by the wall on the block is friction force, that will be 5 Newton, and another force is the normal reaction, which is 12 Newton. Now we can determine the net contact force by the wall on the block. There are two forces which are acting on the block by the wall. One is the normal reaction, that we have calculated the value of 12 Newton. Another one is the friction force F, 5 Newton, and they are perpendicular to each other. Using the concept of vector addition, we can find the value of net force. As the value of R is 12 Newton and the friction force is 5 Newton, hence P will be equal to root over R square plus F square, because these two forces are perpendicular to each other. R is 12 Newton, F is 5 Newton, hence after basic calculation you can get the value of root over 169, and that will come out 13 Newton. Hence the net contact force by the wall on the block will come out 13 Newton. Now the next one is the direction of this force. The direction of this force is given by the angle theta. This angle theta will be equal to tan theta will be equal to F divided by R. That means tan theta equal to 5 divided by 12. Hence theta will come out tan inverse 5 by 12, right?